Guys, listen please. The section of notes I'm using up here is an updated version. There may be some differences. There might be some slides you have we might skip over. So that's okay. So the next section of our unit is about, so we've talked about ecology and sort of the science of how ecosystems work, the interactions within them. Now we're going to start to talk about how humans are affecting the environment, the ecosystems of the earth. And so what's the answer to that question in general? How do humans affect natural ecosystems?
Destroy.
Yeah, generally negatively, right? So humans, like we said, the population of humans is about 7.6 or 7 billion people. And the reason humans can have, there's other species that have 7.6 billion or more individuals. But humans have a unique ability to alter their environment more than any other species. Humans can take a desert ecosystem, build irrigation, and turn it into a city where millions of people live, like they did in Las Vegas. Humans can take hills and forests and bulldoze them and turn it into flat land and build housing developments. We can change the climate by using air conditioning and heating systems. We can drain areas, lakes or swamps. We can build dams and flood areas. We can change our ecosystem more than any other species. And also there are a lot of us, and we consume a lot of resources. So really you could trace back the root causes of the environmental issues that we see back to population growth. Because with the growth of the human population, all those people, all 7.6 or 7 billion people need food, they need water, they need shelter. And that's okay. But as well, they need other things. Or they want other things. They want cars and cell phones, okay, and central air conditioning, and all of these other things that require significant resources from the earth. So the more people we have, the more energy we need, the more resources we need. And so you guys just asked in our question today, well, what happens if our population becomes overpopulated? Well, we're not going to run out of space. That's not ever the issue. We have plenty of space on Earth. In fact, you'll see in this video I show you, what they say is you could take every person on Earth and they would fit into the city of Los Angeles, standing shoulder to shoulder. So it's not that you're running out of room, but you're running out of resources. Is there enough clean water for all those individuals? Are there enough resources to provide for what those people need? And that's the real question. Okay? We'll talk about some of the issues that come about by having this huge population, by using these resources. A couple things here. This is the world population clock. It's not like actually keeping track of how many people are on Earth, but to calculate the world's population, you need to know what it is, and you need to know the relative birth and death rates of individuals, okay? And you use that to sort of mathematically predict the population. So it's not like, oh, somebody is born, we're going to increase this number one, and somebody's born now. But we know the general birth rates and so forth, so we could set up a model and have something like, so like today, 152,000 people have been born, 63,000 people have died. Obviously, that leads to population growth. If in a day you have more people being born than you do dying, then the population is going to increase. And so you see the human population growing. The other video I'm going to show you here is kind of neat. This was made a while ago. This was made by National Geographic. They had a special set of issues when the Earth's population reached 7 billion people. Okay? And so this video just kind of introduces it, helps us sort of visualize what that actually means. How many people is 7 billion, and what does that mean? All right, so you just see kind of to help you understand what 7 billion actually looks like. So if we think about human population growth, this map shows population, or this graph shows the population of humans over the past, 7 or 8,000 years. And so what you see is that for a very long time, for the vast majority of human history, population has been very low. Okay, and you continue, it grew, but at a relatively moderate rate. See a little dip for the plague there, okay, in the Middle Ages. And then all of a sudden we have this change in the graph. This change from arithmetic growth to what we call exponential growth. And we see the population
Why did
skyrocket.
that happen so fast?
That's my question to you. Raise your hand if you think, what changed? Why do we go from this sort of moderate growth to this extreme growth? Emily, go on. People could live longer?
We found ways to be more sanitized.
Yeah.
So less diseases were spread.
So less disease because of sanitation?
We discovered a whole new world in America.
Okay. Well, that didn't cause our population increase, really. Dylan?
Modernized medicine?
Medicine especially. So sanitation, medicine are the big ones.
But after the Black Plague is now what everyone was trying to fix.
So, yeah, science started to become more widespread and more rigorous, and people started discovering ways to help people live longer, to help more babies survive that were born. So, what are the big medical jumps that humans made? There's like maybe 3 huge ones that allowed people to live much longer and have survival rates be much higher. Taya? Yes, surgery, germ theory, in which people start to understand sort of that germs, bacteria, sanitary conditions are linked to disease. That's one important thing.
Vaccination.
Vaccinations is huge. Okay, nobody gets polio anymore, for the most part. It's a disease we've eradicated, completely gotten rid of due to vaccinations. It used to be millions of people died and were disabled due to polio every year. Disease like smallpox has basically been eliminated from the earth. It's a disease that used to kill millions of people. Okay. So that we could go on with our list. Vaccines have been a huge factor in reducing the level of disease, expanding life expectancy, and so forth. There's one other really big one, antibiotics. The development of antibiotics in the 20th century allowed people to survive infections that otherwise could have been deadly. Okay? If in the 1800s you got a wound and it got infected, well, there was no real good treatment. The infection could spread throughout your body, could kill you, you might have to have your arm amputated. Okay, today we have just simple antibiotics that can usually take care of those infections. Okay, and so antibiotics, vaccines, those are really huge ones. And there's no real prospects right now of the population growth decreasing. If you notice from that video, the population went, from 1 billion to 2 billion. That's getting faster and faster when we reach the next billion people. And like we said, those people need resources. We call them natural resources, things that we get from the earth that we depend on for our basic needs and to fulfill sort of things that we want. And there's 2 categories of resources. We call them renewable and non-renewable. I'm sure you've heard that before. What does it mean? What are examples of renewable resources? These are resources that don't get used up. They're replaced over time. David? Wood can be renewable.
Like recyclables, plastic?
Not so much. I mean, that can help preserve. What is plastic made out of?
Polycarbonate.
Petroleum. It's an oil product.
Oh,
Plastics are made of wood.
jelly?
And you can recycle them, but not in an unlimited fashion. So the more plastic we use, the more oil we need. Solar, the sun's energy, right? If you take out your solar-powered calculator and use it, it's not like, oh, we're using up the sun. Quick, turn off your calculator.
What does sunlight?
Right? The sun is going to shine whether we harness that energy or not. We're not using it up.
Like wind power?
Wind power. Again, if you put up a wind turbine to generate electricity, it's not like, uh-oh, if we put up too many of those, we're going to run out of wind. That's not the way it works, right? The wind's going to be blowing whether we harness that energy or not. Okay? So wind, solar, water power, okay, growing food can be done in a renewable manner. Do you have a question, Dylan?
No, I was going to say water gun.
So those are renewable resources. Same time, using wind power in a turbine or solar power in a photovoltaic cell, they don't release pollution. We're not burning anything. Okay? So they're non-polluting sources of energy. Non-renewable resources are the things that we use up. They're not replaced over time. Drew, what's an example?
Coal.
Coal.
Is that like fossil fuels?
Fossil fuels. When we say fossil fuels, we're usually talking about three things. Drew said coal,
Oil.
oil, and natural gas. And gas from within the earth. Those are the fossil fuels. Also, though, things like metals, minerals that we dig out of the ground are considered non-renewable resources. And so those non-renewables, when we take them, they're gone. So some examples, you've seen these wind turbines before. Technically, they're not really windmills. People call them windmills. A windmill used to be used to mill and grind grains and so forth. That's where mill comes from. Really, a better term would be, I would say, a wind turbine. As those large turbine blades spin, they turn a generator, which generates electricity. You'll see them around Herkimer, that area. If you look up north in the ridge up there in Herkimer County, you can see some wind turbines in the distance. If you drive south of here and you're like Waterville, you can see them off in the distance. They're all over the place. We live in an area that's pretty good for wind turbines because we have pretty windy conditions. Photovoltaic cells are becoming more and more popular. Does anyone have them on their house?
Solar panels?
Solar panels?
There's a guy across his house in Lake Economics, and it's like next to their house, and there's this like huge.
Yeah, so there's a couple, so photovoltaic cells, it's interesting. They're becoming more and more popular. Basically, when the sun is shining on them, they generate electricity that you can use in your house. So some go on your roof. Those are getting more popular. They also have some that you put like off to the side of your house. That's probably what you're talking about, a big panel. And they can move also because they want to match so they get the most direct sun's rays. This is pretty cool. These are the newest version of some types of solar panels. These are made by Tesla, the company that makes the electric cars. They're now starting to make solar panels, but they look like regular roof shingles. You wouldn't tell that they're solar panel on your house unless you knew. They're really cool. And they come with a battery to help store that energy. Because if you have these type, if you don't have a battery in your house, like if it's really sunny out and you're burning lots of electricity, well, you don't have any way to use that if you're not using that much electricity. Hydropower, as they let water through a dam like this, it spins a turbine which generates electricity. We can harness energy from within the earth as well. It's called geothermal energy. When I was in Costa Rica, just about every building or house on the roof had a passive solar water heater. These tubes on their house, because they're in a tropical area, it's very hot, the sun's shining oftentimes. On top of the roof, they have basically a container and water goes through this, and as it goes through, it gets heated up, and that's how they heat their hot water there, rather than having an electric hot water heater in their basement or something like we would have.
So with solar panels and giving you energy, would that be like still running if there's a storm and all the power goes out?
No, so like if it's cloudy or at nighttime, these are not obviously generating any electricity. So unless you have a way of storing it, like one of these huge batteries that like Tesla makes, at night you would have to rely on another source for your electricity. So here are the non-renewable sources, digging coal out of the ground, pumping oil, harnessing natural gas from deposits within the earth. All of those are non-renewable sources of energy. When you take them out of the ground and use them, they're gone. They're not coming back. And the other thing is when we burn these non-renewable sources, we generate pollution. Carbon dioxide, carbon monoxide, sulfur, and so forth. And that's an issue which we're going to be talking about. And as we dig more and more out of the ground and there's less and less available, what happens to the cost or the price?
It goes up.
It goes up. The less you have, the higher the price goes. And so eventually we will run out of fossil fuels. And then,
But isn't it gonna take like millions of years?
no,
No? What's wrong?
it's hard to say, but not millions. Hundreds at most.
I'm gonna be honest, if all these like non-renewable resources are like polluting, and we have so many renewable resources, why do we still use them?
Yeah, well, there's a lot of money in selling, because these are cheap. That's the thing. Coal and oil and natural gas are relatively cheap compared to newer technology, which is often more expensive. And so right now, these things are cheaper than mostly the renewable resources. But there will come a point when that will switch. When we run out of non-renewables, they become more and more expensive, and maybe renewables become less expensive. The problem is getting to that point results in a lot of pollution. And so if we can sort of accelerate that, it's going to be better for the Earth. So we're going to talk about a few environmental issues related mostly to pollution. Acid rain is one that's important for us to know about because it affects us in our area. It affects the Adirondacks, especially because their soils are not able to withstand these acidic conditions. Normally, the rain and snow that comes from the sky, if it's unpolluted, has an acidity level, which we measure using pH scale, of about 5.6. Okay, so that's normal rain. However, when sulfur has gotten into the air, which is released by burning sort of dirty fossil fuels, especially coal, when sulfur gets into the air, it goes through a chemical reaction, reacts with water, and forms sulfuric acid. And that sulfuric acid takes the acidity of the rain and it lowers it to 5, 4.5, even maybe 4. And those acidic conditions, as they fall on lakes and forests and ecosystems, some organisms cannot withstand those more acidic conditions. They make the soil pH drop. They make the water pH drop in lakes and streams and rivers, and that disrupts the ecosystem. Many organisms cannot survive those conditions, and so that's a problem. The Adirondacks do not have soils that can sort of buffer that, and so they're affected by acid rain. There are some lakes where you might hike to them and say, oh, look at that lake, how clean it is, and how clear. And it's clean and clear, not because it's natural and pristine. It's clear because the acidic conditions have basically killed all of the living organisms there, and so you don't get plankton and algae and so forth in that water and insects because they can't withstand those conditions. Spruce trees are affected by acid precipitation especially, so they tend to die out.
Is this harmful to people?
I mean, it's not, so people sometimes say, oh, acid rain, well, if it's raining, my skin's gonna melt. It's not like that. But, so, not really. I mean, the conditions are never gonna be so acidic that it would be damaging to us. It's damaging to us in that it damages ecosystems which affect us.
Why is it comparing it to wine?
It's just, this is showing the pH scale. So like the pH of lemon juice is an acidic, like liquid. That's in the between 2 and 3 and so forth. Just giving you an idea. Yeah, it's not battery acid pH. So the consequences, lakes become acidic, forests die off, lakes die off, and that disrupts the ecosystem. Now with a lot of these environmental problems, we're talking about these air pollutants. The problem is that the source of the pollution is not necessarily where the effects of the pollution are felt. This map shows the United States, obviously. And so the orange areas are most affected by acid rain, again, right around us. And the thing is, there's many factories and industries in sort of the Midwest, but when they release pollution in the atmosphere, because in our country the prevailing winds go west to east, much of that pollution, drifts over towards the East Coast and falls on us. So even if, let's say, New York State passes a law limiting the amount of sulfur that factories can release, it may not help the problem all that much in New York State, because many of those pollutants are coming from other areas. So it takes sort of a more national policy of pollution control to really help. And in some areas, they build larger and larger smokestacks. The higher up you release the pollution, the more likely it is to get taken away in wind currents. And so it doesn't just fall directly on the community where the factory is, it gets taken somewhere else. Here you see some effects. These are the spruce forest, okay, that's been damaged due to the acidic conditions of acid precipitation.
Who's that guy?
You can also see it in effects on statues and stuff. If you've ever walked through like a graveyard and seen like the old gravestones used to be made out of limestone, they're like white in color almost. And if you look at the words, you can see they're like eroded away. You know what I'm talking about?
Yeah.
Those were made of limestone. Limestone reacts very easily with acidic substances, and so they've been eroded very easily by these acid conditions. Here's a statue. This is in 1906. This is in Central Park in New York City in 1968. And basically the statue, all of its features have been eroded away over that period of time due to acid rain.
Isn't that what happened to the,
Statue of Liberty?
yeah.
Yep. They had a big cleaning and restoration over the last, 10 years or so. Another environmental issue caused by pollution, a different type of pollution, is smog. Not smog from what book?
Hobbit.
The Hobbit. Okay. Smog is a name for a pollution that's sort of a mixture of smoke and fog. It's caused by pollution released by burning fossil fuels that reacts with sunlight. And it forms a toxic gas that actually can be damaging to people's lungs. People that have pre-existing lung conditions like emphysema or asthma, bronchitis, can be affected even worse if they're living in an area where there's high levels of smog. In areas, in cities where smog is a big issue, often it's areas where there's lots of vehicles and cars, lots of people, densely populated, especially in valleys, because the smog tends to settle in these valleys. And so in the morning weather report, not only will they tell you the day's temperature and if it's going to rain and so forth, they might also tell you the smog index. And that tells you if the smog index is high, you shouldn't go out and exercise outside if it reaches a certain level. If you have respiratory problems, you probably don't want to go outside and inhale that toxic gas that builds up. So solutions are to reduce our emissions of these chemicals. One of the things, if you know anything about cars, somewhere in your car you have a catalytic converter. You ever hear that? That is a special device that as the exhaust from your engine is going and being released out of your tailpipe, this catalytic converter helps burn off some of these emissions.
So it's a good thing.
And so it's a good thing. And that's why you have to bring your car every year to be inspected. If your catalytic converter is not working properly and you don't pass the emissions test, they won't give you the inspection sticker because they don't want polluting cars like that on the road. This is a picture from Beijing. This is a day when there wasn't smog, and the weather affects us a lot. And this is a day when there was. So that's all this toxic pollution.
That's horrible.
LA in California has a bad problem with smog because it's in a valley, because there's lots of cars, people drive everywhere in Los Angeles, so it's a problem. In London in the 1950s, there was what they called the killer smog that killed thousands of people. Special weather conditions came in that kind of kept the wind and so forth down for 5 or 6 days. And at that time in London, people were heating their homes using cheap coal. Factories and power plants were using cheap coal that produced a ton of these emissions. And so it built up. It became so dark they had to have lanterns lit during the day. People died of respiratory illness by the thousands within those 5 or 6 days.
Can you see that video?
Maybe tomorrow. Did anybody in their family watch The Crown?
Yeah.
Do anyone here watch The Crown?
No.
They have an episode that was all about the London smog, if you ever watch it. Yeah, Dylan?
In San Francisco, it's always like really foggy in the morning. Is that
No, that's actual fog and not smog.